now let's continue with the next type of function. It is now the logarithmic function. Okay, so this will be your unit 4, still under module 1. Okay, so our unit learning outcome for this video is the same: to familiarize the process of integrating logarithmic functions, okay, and to integrate problems with logarithmic functions. So we are now focusing again on the logarithmic function. Before we focused on exponential and now on logarithmic. So let's try now to understand how to evaluate and figure out if the problem is integratable by the different types of integration or it is under this logarithmic. So before I will proceed, I want you to recall, okay, about this power formula, the discussion with Engineer Brian Usman. Okay, so power formula, okay, it is applicable if you have a function u raised to a number which is an exponent n multiplied to the derivative of u which is du. Okay, it is applicable in this type of problem. And this is your formula, but if you try to notice, there is a restriction here which is n should not be equal to -1. This one, okay? Because if that is -1, then you will go back to the formula. N plus 1 here on the denominator would make it 0. -1 plus 1 will make it 0. And what is the value? Even if you have the numerator, if your divisor is 0, it will be indeterminate. Okay, so we do not know that one. That's why it's called indeterminate. Therefore, power formula is not applicable in this type of situation. N will be -1. And that will fall now under the logarithmic. Okay, so that will fall here under logarithmic. Okay, so again, another recall for the previous properties which we keep on using. Okay, these are the properties before that we discussed. Okay, so this is the formula for logarithmic integration. That is the power formula wherein your n is -1. So supposedly this u here in our formula in logarithmic is above. But since that is raised, your n now in the power formula is -1, therefore -1 will cross below to make it +1. That's why this is now the form du over u. It is now du over u, not u raised to n, because again your n is -1, therefore that will transfer below to make it +1. That's why it will look this way: the derivative of function u over the function u itself. So if we are integrating this form, then you have this answer here that is just equal to ln u plus t. Okay, you might some will be asking. They might already forget what is ln. What is this ln u? That is read ln. That is the natural logarithm. That is a logarithm with a base e, right? The Euler number e. Your base will be e, so that is natural logarithm. Okay, so this is your formula. Let's try now to have an example. Okay, so again, the formula is here on your upper right side. Okay, so example number 1. Evaluate. Okay, so let's evaluate this problem. This one is on top. Please do not consider this as a bar, no. That is an arrow. Means that is the divisor. That is the division. This is the problem. Integral of 2 dy all over 3y minus 4. This looks complicated already. But if you'll try to look here in our formula, if you can figure out that there is a function below and the numerator is its derivative or differential, that is just ln u plus c. Okay, that is the logarithmic formula. So let's try to say that this 3y minus 4 here below is our u. Yeah, 3y minus 4. Then that is 3y minus 4. Then the derivative of that will be what? Okay, 3 dy plus minus 0, but we do not need to write the derivative of 4, which is 0. So that will just be 3 dy. That is your du. Your u is 3y minus 4. The derivative is 3 dy. Let's try to go back here on top. What do we have here is 2 dy. So the only difference that you have there, 3, supposed to be, but we only have 2. So what are we going to do with that? Since the problem is just a constant, you can again do something. Since that is just a constant, we can add, we can eliminate. Since that is just constant, we can play around because it is allowed in integration to have a balancing factor of constant. Okay, you might be confused with this one. Here, the transformation is just for you to see that it is the same as the power. If you will try to get the entire 3y minus 4, put that on top, that will be a quantity which is a negative 1. That is what we are talking about. U is raised to negative 1, so you cannot apply here the power rule. Therefore, we will apply here the logarithmic formula. Okay, so again, since it is not applicable for power, let's try to see if that is applicable in logarithmic. And according to this, your u is 3y minus 4 and your du should be 3 dy, but we have there 2 dy. We do not need that 2 here. So what am I going to do is I will put that one outside, so that will be outside the integral sign here. Okay, and if I will put that one outside, we only have there dy, but we are supposed to be having there 3 dy. So what will I do? I will add a 3, but do not forget to balance that by 1/3 to take away the effect of the 3 that you added in the equation. Okay, so again, I will repeat, that is 2, but we need 3. So I will bring that out, that will be outside, but we need to put there 3. So in this next step, I will put there 3, but I need to balance that by 1/3. Okay, so nothing happened. I just rearranged. I did not change the equation. But if you try to look again on the new formation, forget about this. This 2 times 1/3 is just a number. Focus here. If 3y minus 4 is your u, the derivative is 3 dy, which is correct. Therefore, we can apply this logarithmic formula. Okay, so we will just follow. Therefore, since this is complete, we will just follow that the answer is just ln of the function u. Do not forget to add the constant t. Okay, so again, I will combine 2 times 1/3. That will just be 2/3. But the answer will be ln u. Okay, so your u is the entire denominator. So ln u plus c. So this is your final answer. Okay, so that is for example number 1. Okay, so try to again try to analyze. There are things that you did not understand. You can ask that one on the separate discussion. Okay, so we will proceed to a second example. Okay, this one. Okay, so evaluate the integral. So as you can see, most of the time, and actually yes, most of the time, for you to figure out if that is logarithmic, there should be a fraction. Unless the original equation is not a fraction, but you can rearrange it into a fraction, which is on a form of du over u. But mostly, the problem wherein this formula is applicable is always in the form of a fraction. So since, again, there's a fraction, let's try to think of the logarithmic formula. If I will consider the denominator, this x squared minus 5x plus 3 as my function, let me try to differentiate that. Okay, so differentiate your u, that will be 2x minus 5. Okay, derivative of x is dx, that will be outside, and so with the dx here. And derivative of 3 is 0. So the derivative of u is just 2x minus 5 times dx. Okay, so that is your du. If you will try to go back to the problem, is that the case? Is your denominator having the numerator as its complete derivative? Yes. So, again, that is just ln formula. Therefore, there is nothing more to discuss about this. We will just apply the formula wherein that is just equal to ln u plus c. Again, your u is the entire denominator since this is my assumption of u. For ln, the entire u plus constant c. Okay, so that's it. Number 3. Okay, so number 3, integral. Again, you are looking at a fraction. Let's try to evaluate if this is integratable by logarithmic. Okay, so if you'll try to look at this, your denominator is x. Okay, your denominator is x, but your numerator is a little bit or much complicated than that. So it should be simpler because, isn't it, the u is to be differentiated and that should be the denominator. But in this case, it looks the other way because numerator is more complicated than denominator. But let's try to figure out. If I will try to expand, since this is just raised to 2, I can expand that one. Okay, rule of algebra, expansion of binomial. Of course, you can recall that one. You forgot about that, but that should be part of you already, since you're already on calculus. Okay, so if I'll expand, 1 squared is 1. 1 times negative 2x is negative 2x times 2 is negative 4x. And then square negative 2x, that will be 4x, positive 4x squared. Okay, so I just expanded this one, nothing happened. Okay, I did not change the equation, I just changed the form. So in this case, let's try to look at this in this case. Okay, it looks complicated, more complicated than the other one. But since there is no exponent, I can distribute the denominator since your denominator is just x, right? That is just a simple equation. I can distribute that one. So that will be this next step here below. 1 divided by x. Of course, you cannot simplify that one. But if I will put there x below 4x, okay, again, I am distributing since that is the rule of fraction. If I want to combine this one, then that will go back there since they have the same denominator. Okay, so 1x, okay, nothing happens since that is the simplest form of that. But negative 4x over x, x and x could cancel. So below, that will just become 4. Okay. On the third term, positive 4x squared divided by x, one of the x will cancel. Therefore, it will make this one 4x only. So let me again look at the equation, the resulting equation. This is just in your distributive property, right? Your equation is just separated now by plus and minus. So you might be asking me, then why is it an example of logarithmic if it is just a distributive? No. Why? Because if I will distribute this integral here, okay, this will be the result. If I will distribute the integral at the same time dx, that will just be integral of dx x over x, which is in the form of logarithmic. So you are going to use still the logarithmic in this one, even if you just applied your distributive property. But in this other terms, no problem. This is just a what? That is just a power, right? X raised to 1 dx. So u raised to n du. Okay, so that is just power. No problem with that. Second, in this middle, that is just integral of dx. That is just x, right? Integral just cancels the effect of d. So that will just be x. But this again is logarithmic. That is where we will be using this logarithmic formula. Okay, again, let x be your u, and what is the derivative of x? That is dx. So yes, that is logarithmic formula. So I will now apply integral of that using logarithmic will be ln u plus c, supposed to be, but again, it is explained before. You will just put the c, accumulate all the c, and that will just be equivalent to 1. C on the last part. Okay. So ln u, that is just the integral of this logarithmic. And again, 4 times the integral of dx is x. So that will just be negative 4x. And then here, 4 times integral of x dx, that is a power rule. So, n u n plus 1 over n plus 1. Okay, so let me simplify it all over. So ln x, 4x minus 4x plus, okay, 4 divided by 2, that will be simplified as 2. So 2x squared plus c. Therefore, your final answer is ln x minus 4x plus 2x squared plus c. Okay, so that is for this example. Again, in the first, in the original form of the problem, it doesn't look like a logarithmic. Why? Because the numerator is much complicated than the denominator, but when I simplified it this way, we ended up with this function here below. That is just a power, and so it is, and this is now the logarithmic. Okay. So again, if you missed something or you did not understand something, we can discuss that one in the discussion part. Okay. So maybe that's it for the logarithmic function. We have 3 examples. So please try this one on your own. Will you please try to apply what we just discussed with these 3 previous examples, then the solution will follow, so that you will check if you get it right or not. Okay, so please answer that one. So for me, before I will end this video, again, let's try to review what we learned. What are the new concepts that we learned here in this video? Okay, so first is the logarithmic formula is usually used for integrals with denominators. Yes, that is what I'm trying to explain a while ago. And when the power formula fails. Okay, when will the power formula fails? If the n in the power formula, which is the exponent, is now -1, which will make it indeterminate. Okay, so we cannot apply their power. That's why let's try to look at the logarithmic, if it is also possible. Because if not, then we need to discuss. We will be discussing the other techniques, okay, or other formulas. Second, the important concept is that the logarithmic formula can be used in conjunction with the power formula. Okay, so it doesn't mean that if you are using a logarithmic, it should only be logarithmic, isn't it? Just like in your exponential, you did not just use exponential alone. You can use that one together with other formulas. The same with logarithmic. Okay, all the formulas. It is not just focused on one. On a problem, it is not just focused on one. It depends. If it could be integrated by exponential, logarithmic, power formula, and other techniques at the same time. So we are just having first the simple ones. And again, this is just to reiterate that logarithmic could be also used with the other formulas. Okay, and the last concept is that if the integral or integrand is a fraction, it is suggested to break it down into individual fractions if possible. Okay, that is what happened in your number 3 example. It doesn't look like integratable by logarithmic, but when we try to simplify this one further and break down, distribute the divisor, it shows us that it is integratable by power and at the same time logarithmic. Okay, so do not just look at the problem and it looks like this, it looks like that. We need maybe it needs some intervention, like we need to simplify for us to look at this formula is applicable or the others are applicable. Okay, so this is a mathematics subject, guys. So we can play with the formula or with the equation as long as you are using the or doing the correct rules of mathematics. Okay, so that is your review for the concept that we learned in this video. Okay, so thank you for listening and understanding what I'm trying to explain here. So there are some questions. Again, the discussion is separated, so please take note of your question, and we will be having a separate discussion for that. Okay, thanks and bye. Please do not forget to answer your exercise, the number 4.